Yeah, good morning to one and all. Myself Y. Himat Kumar, Department of Civil Engineering. So in continuation with the next topic in deep beams. So deep beams are a vital component in many construction projects, providing essential structural support in various applications such as transfer beams, corbel beams and bridge piers. Designing these elements requires a meticulous approach to ensure structural integrity and the safety of the built environment. So in this, first we have to understand what are the project requirements. So the design process commences with a comprehensive understanding of the project requirements. Engineers need to grasp the specific purpose and load bearing needs of the deep beam in the context of the larger structure. These steps involves collaborating with architects and other stakeholders to establish design criteria. So next thing is analyze loadings and constraints. So engineers conduct a thorough analysis of the expected loads and constraints on the deep beam. This includes assessing dead loads such as permanent fixtures, live loads, that is nothing but temporary loads like people or the equipment which is kept on the deep beam, and the dynamic loads such as wind loads, seismic loads, water loads, etc. So additionally, site specific factors and constraints such as available space may impact the design of the deep beam. And coming for the next one, important one is the material selection. Choosing the appropriate construction material is a critical decision where engineers consider factors like the beam's location as well as the load bearing capacity and environmental conditions to select materials that offer the necessary strength and durability. So common materials include reinforced concrete and structural steel will be used in the case of materials for deep beams. Next one is the calculation of calculate the load distribution. So the design process involves complex calculations to determine how the deep beam will distribute the loads for the superstructure to the supporting elements. Example like columns, walls or foundations. So engineers use mathematical models and structural analysis softwares such as StatPro to ensure the beam can withstand the expected loads without excessive deflection or stress consideration. Next one is the consideration of the deflection limits. So designers establish acceptable deflection limits taking into account the occupant comfort and the structural safety. So deep beams are designed to minimize deflection within these limits to prevent damage or discomfort. Next one is the reinforcement and cross section design. To achieve the required load bearing capacity, deep beams are typically designed with a specific cross section and reinforcement which can include steel bars or mesh. The arrangement and quantity of reinforcement are carefully calculated to ensure structural stability. Next one is compliance with building codes. Designers must adhere to local building codes and regulations which dictate minimum safety standards and construction practices. Compliance is essential to ensure the project meets legal requirements and ensures the safety. Next one is the quality assurance. Throughout the construction process, quality control and assurance measures are implemented to verify that the design specifications are met. This may include material testing, on-site specifications and monitoring of construction processes. Next one is the collaboration and the communication. So effective communication and collaboration between the structural engineers, architect and the construction teams are crucial to the success of the deep beam design. Engineers must ensure that their designs align with architectural and functional goals. Next one is the continuous evaluation and adjustments. Designers may need to make adjustments during the construction or as the project progress to accommodate unforeseen challenges or changes in project requirements. Continuous evaluation is necessary to ensure that the deep beam design remains effective and safe. So in summarizing, designing deep beams involves a meticulous and multidisciplinary approach. Engineers need to combine their technical expertise with a deep understanding of project requirements, loads, materials and safety regulations. So the successful design of deep beams contributes to the overall stability and the safety of the structures in a wide range of applications. Yeah. Next one is understanding deep beams fundamentals to provide a solid foundation for understanding what deep beams are and their unique characteristics and their essential roles in structural engineering. And application proficiency, apply deep beam design principles to a wide range of construction scenarios including transfer beams, corbel beams, bridge pairs and more. Next is about the material selection and knowledge. Construction materials for deep beams considering factors such as structural strength, durability as well as the environmental conditions. And also we have already seen what is meant by deflection control, reinforcement design proficiency, compliance with building codes, safety and quality assurance. So coming for the just brief introduction. So design of deep beams, an integral component of structural engineering, plays a vital role in construction of bridges, buildings and various other civil engineering projects. These specialized structural elements are distinguished by relatively small depth compared to their span, and their design and application require meticulous attention to detail and adherence to engineering principles. Deep beams, so the education journey into the design of deep beams seeks to provide a comprehensive understanding of the subject throughout the exploration. So we will examine various aspects of deep beam design, starting with an in-depth understanding of what deep beams are and how they differ from the other structural elements. So we will explore their diverse applications and their vital role in load distribution within the structures. So the process of material selection, load analysis and reinforcement design will be unveiled, emphasizing the importance of controlling deflection and ensuring the structural stability. Thank you all.